Hi everyone, this is the video showing you how to integrate Trigo function by substitution method. Here I have a 6 example. The first one is a sine 5x cos 5x. Let's look at how do I use a substitution method to solve this problem. If I have a sine 5x multiplied by cos 5x, to use substitution method, I will represent the u as either sine 5x or cos 5x. Both also workable. You can, for this example, maybe I use let u equals to sine 5x. After you set your u, you should find your du dx. Du dx equals to 5 cos 5x. From here, we can look at our question. Cos 5x is appear in our question. So I'm trying to find out where cos 5x dx. Alright, try to find cos 5x dx from my equation here. You can see that if I move up the dx to the right, I got my cos 5x dx. And the 5 you move to the left, you have a du over 5. Now you can see that the cos 5x dx, actually it can be replaced by du over 5. Alright, so I highlight here, this one can be substituted as a du over 5. And the sine 5x, of course, will be u. And now everything can be in terms of u. We can write down u sine 5x as a u and the cos 5x dx as du over 5. And again, the over 5 I'm not going to put here. I will bring out, it will become 1 over 5 as coefficient. So now I just need to integrate u with respect to u. Integrate u with respect to u, you have a u squared over 2 plus c. Then you have a u need to replace back by the sine 5x. Then you have a sine square 5x. Remember, if you want to write Trigo and represent it, you want to make it square, you need to write the square in the middle or in between of sine and 5x. Okay, then this is over 5 multiplied by 2, that will be 10 plus c. For the question B, I will factor out the 1 over 2 first. Then I have my integrate cos 3x multiplied by sine 3x dx. Then here I need to replace the u, represent u as represent cos. Maybe in this just now I have let u equals to sine, right? So now we try to let u equals to cos. We can either, the u can be either cos or sine. Both can be used. Then followed by the u dx, you have a negative 3 sine 3x. Because differentiate cos, you get negative, and differentiate 3x, you got 3. So from the question, from this the equation, I can see my sine 3x dx. If I bring up the dx to the right, I got my sine 3x dx, which is appear in my question. You can see that in my integral, I got sine 3x dx. So you can actually find out what is a sine 3x dx in terms of du. From this equation, we can see that sine 3x dx can be replaced by du over negative 3. This can be actually written as a du over negative 3. And of course, this is our u. So now we have planned everything. Everything can be written in terms of u. So now we can write them in terms of u. U cos 3x will be u, and this one will be du over negative 3. So I will write down the du, and then over negative 3, I will just bring out to become a negative 1 over 3. So rewrite it into the proper form. I got negative 1 over 6 as a coefficient, and integrate u with respect to u. Just write down the coefficient. Integrate u with respect to u, you have a u squared over 2 plus constant c. And now you're going to replace back your u as your cos 3x. So you got a cos square 3x because you have a u square over 6 multiplied by 2, that will be 12, plus constant c. For the question cotangent 3x, I'm going to use substitution method as well. Before this, you need to rewrite it into the form of a cos 3x over sine 3x. Because cotangent is equals to cos over sine. Then we will let the u, to substitute, we let the u equals to the denominator, that is my sine 3x. So once you set your u, you must find your du dx. Du dx equals to 3 cos 3x. Yeah, this is differentiate. And cos 3x, I bring up the dx to the right, I have my cos 3x dx. Cos 3x, bring up the dx, I got cos 3x dx. This is equals to du over 3. Meaning that the cos 3x dx, which is appear in my function here, I can substitute it as a du over 3. Alright, then 1 over sine 3x, it can be written as a 1 over u. So finally, I have a 1 over u du, and 1 over 3 I bring out. I put it as a coefficient. I got 1 over 3, integrate the 1 over u with respect to u. Then integrate 1 over u with respect to u, you have a log u plus constant c. Then finally, we should substitute back the u as a sine 3x. Means that you have a 1 over 3 log sine 3x plus c. Similar to the question C, now we're going to integrate tangent 5x. We need to rewrite it into the form of a sine 5x over cos 5x. Integrate this with respect to x. Yeah. Then to use substitution, I will let u equals to cos 5x, and followed by the du dx, I have a negative 5 sine 5x. Remember, differentiate cos, you have negative. Alright, after you have find the du dx, you can see that you can actually replace your sine 5x dx, which appear in your question. In your integral, you have sine 5x dx. You can actually substitute it as a du over negative 5. How do I get this? I just bring the negative 5 to the left hand side, bring the dx to the right. Then you can start to substitute. You can write down your function in terms of u. 1 over cos 5x, it can be written as 1 over u. Sine 5x dx, it can be du over negative 5. Negative 5, just bring out as coefficient. You got negative 1 over 5. So write down negative 1 over 5 and integrate 1 over u with respect to u. You have a log u. Then finally, we need to substitute back the u as a cos 5x. So we have a negative 1 over 5 log cos 5x plus c. For this question, I will replace the u as I'll replace the cos power of 3x by the u. Replace the cos x by the u, so that I can find the du dx in terms of sine. Du dx is equals to the negative sine x. Why I need to get this? Because I plan to substitute the sine dx in terms of u. Alright? So here I got my sine x. If I bring out the dx to the right, I got my sine x dx. Meaning that this can be replaced by negative du. So this can be replaced by negative du. And 1 over cos cube x can be written as 1 over u cube. So du. The negative here I bring out as a coefficient. So now we just integrate u power of negative 3 with respect to u. Integrate this, you have u power of negative 2 over negative 2. Just increase the power by 1 and divided by the number that you have increased. Alright, plus constant c. So negative, negative, you got a positive. So you have a 1 over 2 u squared. the u square, I substitute back with the cos square plus c. For the example F, I have integrate sine power of 3 over cos power of 2. So for this question, same thing. I will let u equals to cos x, denominator cos x. Why I do this? Because once I find du dx, I got my negative sine x. So here, there is a sine x over here. When you split the sine power of 3 into sine power of 2 multiplied by sine x, you can see your sine x dx, and this can be replaced by, here do you see my sine x? If I bring up the dx, I got my sine x dx, and this can be replaced by the negative du. Later on, this is going to be negative du, alright? And the sine square, how can I substitute in terms of u? I actually can use the identity, change the sine square into 1 minus cos square. Alright? And you have your sine x. I write down the question first. Okay, later on we will change. Okay, we will change all together. Alright. After that, this is 1 minus. Okay. So this identity, actually I got it from here. I write down the identities. Sine square theta plus cos square theta equals to 1. I'm using this identity to change the sine square x into 1 minus cos square x. Why I do this? Because just now we have represented the cos x as a u. So sine square x is no way can be u, so I will use the identity. I convert it into the 1 minus cos square x so that I can substitute in terms of 1 minus u square. Alright, then now I start to substitute. 1 minus cos square will be 1 minus u square. And over cos square means over u square. Sine x dx going to be the negative du. And the negative I bring outside. So now I have a numerator 2 terms. Denominator only 1 terms. Actually, we can split them into 2 separate terms. Then we can start to integrate. 1 over u square, I will write down as a u power of negative 2. And negative u square over u square actually equals to 1, negative 1. Then now you integrate with respect to u. Alright, then what do I have later? I have a negative, just copy down. Integrate u power of negative 2, you have a u power of negative 1 over negative 1. Minus, integrate 1 with respect to u, you have u. Okay, so I put a bracket here, plus a constant c. Then you can simplify first. Negative multiplied by negative, you have a 1 over u, positive 1 over u. And negative multiplied by negative, another u plus c. Final answer should be in terms of x. So just now you have replaced your cos x as a u. So now we replace back the u as a cos x. You got a 1 over cos x plus c. Here are the examples that find the integrals by using the substitution method. So for the next video, we're going to discuss about the integrals, integrals of Trigo, which involve the Trigo identity. Thank you for watching.